We will in the following be presenting an alternative interface designed for interactive virtual 3D environments that uses a combination of eye tracking and gesture recognition. The current standardization for interactive virtual 3D environments uses a mouse which does not offer the desired 6 degrees of freedom needed in 3D environments. As such, our main motivation for this project stems from the curiosity of investigating the potential use of spatial input alongside gaze-based object acquisition in order to create a generally more efficient interface for said environments. Our final problem statement is as follows. How will a gaze and gesture interface designed and implemented for interactive virtual 3D environments affect the performance of users when manipulating the viewport and objects in a given 3D scene, where we define performance as the measurement based on time? Through a thorough analysis and a user-centric design process, we designed and implemented a gaze-gesture interface for a 3D context. This alternative interface was compared to the gold standard of a mouse and keyboard. As such, we hypothesized that a difference exists between the two interfaces in terms of completion time when performing simple 3D tasks in interactive virtual 3D environments. The experimental setup consisted of a 24-inch monitor placed on a raised stand together with an eye track to allow eye tracking. A lead motion was placed in front of the participants to track their gestures. The control condition utilized a standard keyboard and mouse with scroll wheel. Participants were asked to place 3D objects into specific locations using both interfaces, and the completion time was logged. The data showed that the mouse and keyboard setup was significantly faster than the gaze and gesture interface. In essence, this means that the alternative interface featuring gaze and gesture failed to outperform the mouse and keyboard setup, and thus the alternative hypothesis was refuted. We concluded that a traditional mouse and keyboard interface generally performed better than our alternative interface. However, we do argue that these results need to be considered in respect to the methods involved in gathering them. We ultimately suggest that a gaze and gesture interface might still prove the more efficient solution for interactive virtual 3D environments, but needs to be re-evaluated using more appropriate methods before the suggestion can be confirmed.